When looking at the modern U.S. military arsenal, it is easy to assume success is measured strictly in explosive yield. However, a massive warhead has no tactical value if it gets shot down. Today, a missile's utility is determined by its ability to reliably penetrate overlapping high-tech enemy air defenses. This creates a tactical dilemma. On one side of this simulation, we have a cruise missile flying at a leisurely 885 kilometers per hour. On the other, an intercontinental ballistic missile entering space at Mach 22. Military planners utilize both because they solve entirely different problems. This chart plots the two primary methods for surviving a modern radar grid: speed and stealth. These are often mutually exclusive. If you fly fast, friction generates immense heat that lights up thermal sensors. If you fly slow, you reduce that signature, but you are easier to shoot down if caught. Anchoring this calculation is the launch platform. Firing from land, sea, or air places strict physical constraints on weapon speed and stealth. Combining a launch platform with a survival strategy results in the penetration equation. This framework is what military planners use to determine if a weapon's technical specs align with the specific risks of the mission. Because of these trade-offs, there is no universal weapon in the U.S. arsenal. Success relies on the precise alignment of platform, speed, and stealth required to crack a specific target. This decision tree outlines the military's actual selection framework, starting with the heaviest logistical variable, the launch platform. Everything begins by evaluating the vulnerabilities of land, sea, and air. A land-based underground setup allows for massive payloads and a constant 24-hour alert status. The Minuteman III weighs 32 metric tons and requires a permanent, hardened concrete silo to house it, meaning the enemy always knows its location. Mobile land launchers like the M142 HIMARS provide commanders with tactical mobility, allowing them to hide until the moment they fire. However, their operational range is strictly confined by geography and the availability of solid road networks. Sea platforms offer a different path. A nuclear submarine cruising quietly underwater provides global reach and hidden origins. But these vessels require extreme financial investment, and once their launch tubes are empty, they must return to a friendly port to reload. Finally, air platforms like the B-1B Lancer bomber provide unpredictable attack vectors. They can deploy weapons rapidly across the globe, but the aircraft's maximum takeoff weight places strict physical limits on the size and number of missiles it can carry. Before a commander considers the explosive power of a warhead, they must first accept the specific logistical vulnerabilities of their chosen launch platform. Once the platform is selected, planners move to the first output strategy, kinetic speed. For certain high-value targets, moving too fast for an enemy interceptor to track is the most reliable way to guarantee a hit. The ATACMS accomplishes this by flying a semi-ballistic trajectory. It launches high into the atmosphere and descends at over 3,600 kilometers per hour. That steep, arcing flight path makes it difficult for standard defensive systems to calculate an intercept vector in time. At the extreme end of kinetic speed, the Triton II D5 and Minuteman III ICBMs climb thousands of kilometers into space. They return at speeds exceeding Mach 18, projecting a level of force that is nearly impossible to stop once in its final descent. The new long-range hypersonic weapon evolves this further. It uses a heavy rocket booster to reach extreme altitudes, then detaches an unpowered glide body that maneuvers towards its target at over 7,600 kilometers per hour. However, sheer velocity creates a strategic trade-off. Pushing through the atmosphere at hypersonic speeds generates an immense thermal signature that infrared satellites can detect immediately, which may reveal your launch location to the enemy. Speed is equally critical on defense. The Patriot PAC-3 MSE interceptor travels at over 5,200 kilometers per hour. It utilizes hit-to-kill technology, physically colliding with the incoming threat to obliterate it through raw kinetic energy. Relying on kinetic speed increases the probability of target destruction, but it sacrifices the element of surprise and can lead to immediate escalation. If broadcasting your location is an unacceptable risk, planners pivot to the opposing strategy, evasive stealth. To hide from radar, these missiles sacrifice velocity. By flying at subsonic speeds, they avoid thermal friction and can travel under the radar horizon. They use terrain contour matching and autonomous sensors to navigate without emitting traceable signals. The BGM-109 Tomahawk operates in this role, navigating complex geography and hugging the ground for over 1,600 kilometers. This allows it to strike command posts with precision, while the launch platform remains safely out of the enemy's reach. The trade-off is time. Subsonic flight takes significantly longer to reach a target. This gives mobile enemy assets time to relocate and makes the missile vulnerable to simple visual or acoustic detection by ground forces. The SM-6 functions as a multi-tool within this category. It integrates an active radar seeker, allowing it to autonomously switch roles mid-flight, handling anti-air defense, terminal ballistic interception, or acting as an anti-ship weapon. This versatility is expensive. The SM-6 carries a high production cost and occupies limited vertical launch slots on naval vessels that could otherwise hold specialized offensive weapons. Ultimately, stealth and multi-role weapons trade immediate speed for the precision necessary to operate in heavily fortified or complex environments. This 3x3 matrix maps launch platforms against strike strategies, plotting all 10 missiles into their specific operational niches. For rapid local battlefield responses against moving targets, commanders prioritize land or air platforms combined with speed. This makes the ATACMS, or the Patriot Interceptor, the logical choice for immediate engagement. To dismantle a heavily defended command center without risking pilots, planners look to sea or air platforms utilizing evasive stealth. This is where the Tomahawk and LRASM excel, slipping through a radar grid undetected. For national defense that relies on undeniable power, the strategy shifts back to sea and land platforms with ballistic or hypersonic speed. Systems like the Minuteman III and Trident II are designed to reach any target on the globe using sheer velocity. The U.S. arsenal functions as an overlapping network, where the speed of one platform covers the inherent vulnerability of another. No single missile handles every scenario. Instead, these systems work together to ensure that at least one path to the target remains open.